Hello everybody and welcome to this video. In this video I'm going to show you how a one-factor CFA model is specified and estimated using the graphical method in EQS. So this is the process of doing the job. It has 5 steps. In the first step, the EQS system data file is generated. Then we will draw the model. Then based on this diagram we will create the model file, and then we will create command file, and then we run this command file to see the output in the output file. And this is our example. So the factor in our example is supervisory support, and it has 5 items. So these items are the dependent variables in our model, and we will have equations for these dependent variables in our model file. Also note that the fixed parameters are in red color and the free parameters to be estimated are represented by these asterisks. So all of the variances of the error terms, the variance of this factor, and also these 4 factor loadings will be estimated in our analysis. Alright, now let me open EQS. Okay, my data is in a SPSS file. So I just select this file and then I click open. Okay. Note that when you open a SPSS file in EQS, the file is automatically converted into an ESS file and also it is saved. So the next step is to click on this button, which is the new model helper button. And there are different options here, and I select factor model. Okay. So as you can see, the list of the variables is displayed here. So all of the variables in my data set can be seen here. And the variable that I would like to add to this model are these variables. Supervisory support number 1 to number 5. So I select these 5 and then click on this button. Note that factor 1 or F1 is supervisory support. And then I click on add. Then I click on next. And now here, because I don't have any structural equations or factor regressions, so basically you don't need anything to do here, and we can simply skip this step. And then it is done. Our model has already been specified here. Now let me save this model. I save this model as model 1. And basically this is the EDS file. So this is the EDS file. Okay, now the next step is to click on build EQS and then click on title specifications. And when I click on this, then the EQX file is generated based on the diagram file. So you can see that all of the equations and the variances based on the model can be seen here. And we really didn't write any equations here. All of these have been created based on the diagram file that we already specified, the model that we already specified in the diagram file, I mean. Okay, now here there are a few options. For right now, the most important option is that you just select maximum likelihood as the normal theory estimator. And also, given the fact that in many situations we normally deal with multivariate non-normal data, it is always a good idea to select robust methods here so that the corrected fit indices, chi-square statistics, and also the standard errors are printed in the output based on the work by Satora and Bensler. So I just click OK, and now you can see that the EQX file has already been generated here. Let me just show you what we have here. Under the specifications keyword, we have data. So this is the path of our data. We have 98 variables in our data set. We have 2,324 cases in our data set. Our method of analysis is maximum likelihood and robust maximum likelihood. Our analysis is based on covariance structure, and our data is raw data. Also, you can see that we have the labels here. So because we have 98 variables, all of the variables from V1 to V98 can be seen here, and the variables have been numbered according to their position in our data set. We have the equations, variances. Also, we don't have any covariances in our model. That's why you cannot see anything under covariances. Also, by default, all of the fit indices are displayed in the output file, and also the format of the parameter estimates is based on equation. I really don't prefer this one, so I'm going to change this equation format into compact format so that the results becomes much easier to understand. This is my own personal preference. So I just click on print, and here I select compact. Also, I'm interested in model implied covariance matrix. I select this because I want this to be displayed in the output file, and also the correlation of parameter estimates. And that's all. If I click OK, you can see the changes that are made under the print keyword. Now you can see that the model covariance matrix is displayed, and also we will have the correlations between the parameters being displayed in the output, and also the format of the parameter estimation result will be the compact format. Okay, so let me save this file. This is the EQX file. I am just going to save it with the default name model1. And now the last step is to run the model. So when I click on this, what happens is that the EQX file is converted to an EQS file, and also it is run, and we can see the results in the output file. So I just click run EQS. All right, this is the message from the software which says that the estimates have been inserted in the diagram file. Okay, and this is basically the output file. If I scroll down, you could see a lot of statistics here in this output file, but I will talk to you about these statistics in the next video. For right now, just let me show you the EDS file, that is our diagram file. And if you would like to display the factor loadings on this diagram file, you can simply click on view menu, and then you can select estimates and then standardized solution. And now you can see the factor loadings here. If you would like to export this diagram file into an image file, you can simply click on file and then click on export, and then you can save this as an image file somewhere, and then you can edit that and you can use it in your publications. So that was how we can specify and estimate a CFA model in EQS. In the next video, I will talk to you about this output file, and I will show you different statistics that we have in this output file. Thank you very much for watching, and I hope you like this video.